With some review of matrices. So for number 5 here, we're going to multiply matrix C times matrix B. Before we do this, let's just make sure it's going to be possible. Matrix C has 2 rows and 3 columns, so it is 2 by 3. Matrix B has 2 rows and 2 columns, so it is 2 by 2. And notice that those inner dimensions do not match. This is not possible. So we'll move on to B minus D. B is 2 by 2. D is 2 by 2. In order to multiply, we had to have inner dimensions match. In order to add or subtract, we have to have all dimensions match. 2 by 2, 2 by 2. This is going to work. So 3, negative 2, 5, 7, minus A, C, B, D. Okay? 3 minus A is just that. 3 minus A. Negative 2 minus C. Negative 2 minus C. 5 minus B. And 7 minus D. So that is our answer. Negative 3 times A. Scalar multiplication is always possible no matter what the dimensions are. Okay, so we multiply everything inside by negative 3. So we get negative 12, negative 6, negative 18, negative 21, and 6, 12. All right, a triangle represented by vertices, a triangle with vertices represented by matrix C is translated. So translation is addition. So that's 2, 0, negative 3, 0, 3, 5. So that means that the coordinates of the triangle are 2, 0, 0, 3, and negative 3, 5. And it's being translated left 5 units. So that means we're going to add negative 5 to all the x's, and up 1 unit. Up is positive, so we're adding a positive 1 to all of the y's. Okay, so that gives us negative 3, negative 5, and negative 8. And then the bottom is 1, 4, 6. So the new coordinates are negative 3, 1, negative 5, 4, and negative 8, 6. Matrix A times matrix C. Matrix A was a 3 by 2 matrix, and matrix C is 2 by 3, so this is going to be possible, and the result is going to be a 3 by 3 matrix. Okay, so matrix A from the top looked like this: 4, 2, 6, 7, negative 2, negative 4. So there's matrix A. Matrix C, 2, 0, negative 3, 0, 3, 5. Okay, so I need to multiply those two matrices. So when I multiply the first row by the first column, then by the second, and then the third column. So I've got 4 times 2, which is 8, and 2 times 0, which is 0. 8 plus 0 is 8. Then the first row by the second column, 4 times 0 is 0, plus 2 times 3 is 6, so 0 plus 6. And then by the last column, 4 times 3, that's negative 12. 2 times 5 is 10, negative 12 plus 10 is negative 2. So that is our first row. Then we've got the second row by each column. 6 times 2 is 12, 7 times 0 is 0. Add those together and you get 12. 6 times 0 is 0, plus 7 times 3, 21. 6 times negative 3 is negative 18. 7 times 5 is 35. Negative 18 plus 35 is 17. So on to the third row. negative 2 times 2 is negative 4. Negative 4 times 0 is 0, and that adds to negative 4. 0 minus 12, and 6, and negative 20 is negative 14. A triangle represented by C rotated 180 degrees. So C is 2, 0, negative 3, 0, 3, 5. So that's matrix C, rotated 180 degrees. Rotation of 180 degrees means we multiply by negative 1, 0, 0, negative 1. Okay, so first row by first column, negative 2 plus 0. By the second column, 0 plus 0. And by the third column, positive 3 plus 0. And then the bottom row by each column, 0 plus 0. 0 minus 3. And 0 minus 5. So our new triangle has coordinates of negative 2, 0, 0, negative 3, and 3, negative 5. I'm going to add something to the bottom here. A little bit of a challenge. We are going to multiply these two matrices, if it's possible. So there's 3 rows by 2 columns, and this is 2 by 2. The inner dimensions match, so it is possible, and our result will be a 3 by 2 matrix. So the first row by the first column, I've got 5A plus 0C. 0C is 0, so I'm just left with 5A. The first row by the second column, 5 times B is 5B, 0 times Z times D is 0, so I'm just left with 5B. Second row by each column, 4A plus 1C is 4A plus C. 4B plus 1D is 4B plus D. And the third row by each column, 0A plus 2C is 2C. And 0B plus 2D is 2D. So there is my 3 by 2 result.